Hi, today we're going to be talking about unit conversions, and this is usually covered in the first part of your chapter, or the first chapter of your textbook, and they usually deal with just movement of numbers within the metric system, essentially. For these problems that we'll be working on today, they're going to be coming from the Silberberg book, Chemistry, the Molecular Nature of Matter and Change, and it's going to be the 6th edition. Again, all of these are coming from Chapter 1, so these are real basic problems that help you get started learning this chemistry stuff. Let's see. For the first problem, we have this. Okay, so what are we actually looking for? We know picometers, and we need to go to the radius in nanometers. Okay, so that's what we're looking for. We need to go from pico to nano. Okay, so what information do we have in the problem? Let's see, the average radius of the lysozyme molecule, which is found in tears, and it's actually pretty neat what the lysozyme actually does. It's an enzyme that helps break down bacteria that can form around your eye. So it helps keep your eye clean and keep you healthy. So it's actually a pretty neat little enzyme. Your cells have something similar in them that's a lysosome, which is used to detoxify and break molecules down. So it's actually it's more to break down than it is to detoxify, but it's about the same thing. But for here, we know that the size of the average radius of the molecule is 1,430 picometers. Now, when I set up these problems, I always like to, like I said, go from what I know to what I don't know. And I do it a couple of different ways, but the one way I really like is I use, it looks like a big fraction bar, and I break it down. Some people use parentheses. Your professor may have you doing parentheses. I do it like this so it's a little bit easier for me to see. The more that's in the way, or when it breaks up, it kind of causes me problems, so I just kind of keep it all together. But what I do with when it comes to the problems, I'll take whatever I'm at and take it to the base unit. So in this case, I'm at picometers. I want to go to meters. If this had been liters or grams, we'd be going to grams and or liters. And then I'll take it down to what I'm looking for the nanometer. So I want to take it up to the base unit and then back down or continuing further up from the base unit to where I'm trying to go. So I know that 1 picometer is 1 times 10 to the minus 12 meters. So now you're looking at what I've got so far. I've got it going from picometers to meters, but I'm not quite to the end yet. I need to find my nanometers. So I do know that 1 nanometer equals 1 times 10 to the minus 9 meters. So let's see, we're going from picometers to meters, and meters to nanometers. And that's what we're looking for. We're looking for the nanometers. So we're pretty much ready to figure this thing out. Now, once I've set it up like this, what I can do, or what I want to do next, is create a numerator and a denominator. And I can do that by multiplying everything across the top, which across the top is going to give me 1.43 times 10 to the minus 9 nanometers. And down here, I'm going to divide, or I'm going to multiply both of these together and come up with 1 times 10 to the minus 9. Now you're probably looking, well, what happened to the meters and the picometers, and why did he put nanometers at the top? That's another reason why I like this particular setup. I can see where I need to what cancels out. And that's the other thing I'd recommend also, is making sure you put your units with each number. It helps you keep track of what's going on. So I can see that here picometers and picometers cancel. I can see here that meters cancel with these meters. So between both of those, the only thing I'm left with is nanometers. So here it is, down here. It makes it nice to see that I'm following through. Okay, I did end up where I wanted to go, to the nanometers, and my units have shown that by what was able to cancel out. So, and look at this, very nice math. If I divide this into this, guess what I get? 1.43 nanometers. And that's going to be my final answer. So essentially what we did, we determined what our problem was. We needed to find the radius in nanometers from picometers. So we drew our little plan there. We went from what we knew, the 1430 picometers, we converted it to meters, and then converted those meters to nanometers. And then using our basic math, we came up with the final answer. It's not a bad problem, but there's several keys to it. Number one, identifying what you need to find. Building a roadmap. Your book may or may not talk about that, but it's very, very important. You definitely want to build a roadmap. And once you build your roadmap, you can build your conversions the way you need to. Don't be scared to use your tables at first to remember that 1 picometer is 10 to the minus 12 meters. 1 nanometer is 10 to the minus 9 meters. Don't be scared to use your tables. Please use your tables until you learn. And once you start doing a lot of these problems, this will become second nature, and you'll realize what's going on a little bit faster as you start seeing the trends, especially with the math where it's easy to see that if I divide this by this, it's going to cancel that out. So let's see, that'll cover that one problem. And if you're wondering, I don't know if anybody's still using the Silverberg book. It's problem 1.26 in the Silverberg text.